Our planet Earth is surrounded by space. It has a natural magnetic field with magnetic north and south poles and is surrounded by a layer of gases that make up our atmosphere. There are other planets near to us in space, as well as moons and asteroids. Along with the Earth, they form our solar system. The Sun is about 93 million miles from Earth. It sits right at the center of our solar system and provides us with heat and light. Because our planet is not alone in space, things that happen in our solar system and even further away can affect our lives here on Earth. One of these things is a phenomenon called space weather. The term space weather describes conditions in space near Earth. These conditions are always changing because the Sun constantly releases a stream of charged particles into space. This is called the solar wind. Occasionally, there are sudden large disturbances. We call these severe space weather events. These occur when the Sun's activity causes solar wind storms, or when it releases bursts of energy, a little like the weather here on Earth, but on a much bigger scale. However, space weather does not include things like meteor showers. Space weather is what we call a natural hazard, because it creates naturally occurring events that can disrupt our lives on Earth. There are different types of space weather. There are high-speed solar wind streams caused when the stream of particles released by the Sun, the solar wind, has a high-speed rush. Or the Sun can produce a massive explosion of particles and magnetic fields called a coronal mass ejection. The Sun can also release intense flashes of light known as solar flares. Or it can generate radio signals called solar radio bursts. Space weather events radiate from the Sun in different directions. Most of the time, it's away from Earth, but sometimes it's directly towards us, and could even be powerful enough to reach us. We have all probably seen pictures of one type of space weather. People lucky enough to see the northern lights are actually witnessing the solar wind energizing particles inside the Earth's magnetic field, and these cause the Earth's atmosphere to glow. This is one effect of a magnetic storm, triggered when a high-speed burst of material from the Sun interferes with the Earth's magnetic field, for example, as a result of a coronal mass ejection. Another type of storm is a solar radiation storm. This takes place when a burst of particles from the Sun happens at such high speed and energy that they enter the Earth's atmosphere, for example, as a result of a solar flare. Space weather can have a range of effects on spacecraft, satellites, and aircraft. It can also affect communication systems on Earth, as well as transportation networks, pipelines, and power grids. These impacts are often very small, but could be larger if a severe space weather event happens. Space weather isn't new to us. There are a number of historical records, including Victorian newspaper articles and a PhD thesis about a magnetic storm in 1909. These records show disruptions to telegraph systems and telephone lines. Back then, space weather was a source of interest, but it caused little damage. There is much greater potential for space weather to affect our lives in the 21st century. Today's systems of communication, energy, and transportation are much more complicated and more vulnerable to space weather hazards. Governments, industry, and organizations around the world want to know more about space weather, including how we predict it and how we prepare for its possible impacts. Above us, space weather can affect aircraft, satellites, and spacecraft. Down here on Earth, it can disrupt communications, transportation, and energy. Although severe space weather events are rare, the possibility of one happening in the near future raises some important questions. What is the best way to communicate with people about space weather and its potential impacts? How might we prepare for such an event? Who does what if such an event happens? What do we prioritize?